Hi everyone, today we're going to learn how to graph polynomial functions in standard form. If you recall from our last classes, we learned how to graph polynomial functions in factored form and with multiplicity. Today you will be graphing polynomial functions in standard form, and you know you are successful when you're able to sketch polynomial functions in standard form. We're going to do a few examples together. Just like in the other polynomial functions in factored form, we're going to list key features, which include orientation, degree, intercepts, and then we're going to graph the function. So let's start with orientation. We know that this has a positive orientation because the leading coefficient is positive. So orientation is positive. We also know that the degree is 3 because it is the largest exponent in our function. So it's a third degree polynomial, also called a cubic polynomial. And because it has positive orientation and it's a third degree polynomial, we know that at the ends it's going to go down to the left and up to the right. And the difference between this one and the other ones you've been working with is that this is not factored, so we're going to start by factoring the polynomial functions to be able to find the zeros and give the x-intercepts. So I'm going to group the factor by grouping, which means I'm grouping the first two terms together plus the last two terms together. And then factor out the greatest common factor. In the first parentheses, I have an x squared as the greatest common factor. And if I divide 2x cubed by x squared, I'm left with 2x. X squared divided by x squared is 1. Second parentheses, I have a common factor of -9. And if I divide negative 18x divided by -9, I have 2x. -9 divided by -9 is 1. And those should be the same. They are. So that's one of my factors, 2x plus 1. And my other factor is x squared minus 9. X squared minus 9 is the difference of squares, so that could still be factored. So I'm going to continue factoring. So that is going to give me an x plus 3, x minus 3. And I'm finding the zeros, so I'm setting each factor equal to 0 and solving for x. So 2x plus 1 equals 0. X plus 3 equals 0. And x minus 3 equals 0. And then if we solve each one, we get x equals -1/2, x equals -3, and x equals +3. And we need to write those as intercepts. So intercepts would be -1/2, 0, -3, 0, and 3, 0. And then we also need to find the y-intercept. So to find the y-intercept, we're setting x equal to 0 and solving for y. Remember, f of x is your y. So I'm just going to write it as y. So y equals 2 times 0 to the third plus 0 squared minus 18 times 0 minus 9. So if I multiply and add all that up, I get -9. So y-intercept, when x is 0, y is -9. And then we're going to graph the function by plotting all the intercepts. So -9 is about right there. And -1/2 about right there, -3 and +3. And I know that because it's a cubic polynomial, it goes down to the left. It's going to go through that intercept, down, and then this way, up that way. So it goes through all my intercepts because I don't have any factors that are squared, so there's no multiplicity. It goes through all of them. And we graph the polynomial, found the key characteristics, Let's try another example. Okay, so again, we're going to find all key features of this polynomial function. Let's start with orientation. Orientation is positive because the leading coefficient is positive, so it has positive orientation. The degree is 3 because the largest exponent is 3, so this is a third degree polynomial, also called a cubic polynomial. And we know that because it has positive orientation and it's a cubic polynomial, we know that it goes down to the left, up to the right. So we know what's going to happen at the ends, or what it's going to look like at the ends. And then this is not factored for us, so because it's 4 terms, I would try to factor, but if you try factoring this one, and I'll just show you, it is not factorable. So if we try factoring, we would group the first 2 terms together and the last 2 terms together. And I think you could already see that it's not going to be factorable. So these are not the same, the 2 factors, so this is not factorable. So we're going to use the x-intercept that is given. So the 0 for that would be x equals 1. Sorry, negative 1. X equals negative 1 is a 0, and I'm going to use synthetic division. So if I do synthetic division, I get negative 1, and then list my coefficients, which are 1, 9, 23, 15. And then we're going to bring down the 1 and multiply. Negative 1 times 1 is negative 1. Add, multiply, add, multiply, add. And then interpret your result. We know that this is the remainder, constant term, x squared. So I'm left with x squared plus 8x plus 15. And I need to find the remaining zeros. So I know that one of them is negative 1. I need to solve that quadratic by factoring. So if I try factoring that, I'm going to rewrite it over here so that I could show my work. So if we multiply a times c, we get 15x squared. And then middle term, 8x. Factors of 15x squared that give us 8x when we add them are 3x and 5x. So then our factors are x squared plus 3x plus 5x plus 15. Factor out common factors. So I have a common factor of x in the first parentheses. And in the second parentheses, I have a common factor of 5. And now this does work. So x plus 3 is my common factor. And my other factor is x plus 5. And if I set each factor equal to 0 and solve for x, I get x equals negative 3 and x equals negative 5. So now I need to write all that as intercepts because they're asking us to list intercepts. So intercepts would be negative 1, 0. That's the one that was given, that one. And then we found the other two, negative 3, 0, negative 5, 0. And all I need now is my y-intercept. And I find that by setting x equal to 0 back into the original equation. Remember, f of x is equal to, is your y. Plus 15. So when x is 0, y equals 15. So y-intercept is 0, 15. And then I need to plot all that. So 0, 15 is the y-intercept. And then I have an x-intercept at negative 1, 0. another one at negative 3, 0, and another one at negative 5, 0. And I know that it goes down to the left, it goes through those intercepts, and then up through the y-intercept. And I've given all the key characteristics, which are positive orientation, third degree, all the intercepts, and graph the function. Okay, let's do one last example. So we're giving the same information, orientation, degree, all intercepts, and then we're graphing the function. So we know that the orientation is positive because the leading coefficient is positive. So basically, if you had a negative way in the front, that would be a negative orientation. This is a +5, +5, so it's positive orientation. The largest exponent is 3, so this is a third degree polynomial, also called a cubic polynomial, and I know that because it has positive orientation, third degree polynomial. I know that the end behavior, or what's happening at the ends, is going down to the left, up to the right. And it's not factored for me, so I'm going to have to factor this to find all the zeros and then write those as intercepts. So if I factor by grouping, I group the first two terms together. Plus the last two terms together. And then factor out any common factors. So in the first parentheses, I have a common factor of x squared. And that if I divide by x squared, both of those terms, I'm left with 5x plus 4. Second parentheses, I have a common factor of -4. And if I divide both terms by -4, I'm left with 5x plus 4. So I have a common factor of 5x plus 4. And my other factor is x squared minus 4, which is the difference of squares. So I could continue factoring that. So I'm left with 5x plus 4, x plus 2, x minus 2. And then I'm finding the zeros, so set each factor equal to 0. I'm setting all this equal to 0 actually. Set each factor equal to 0 and solve for x. So here, subtract 4 from both sides. I get 5x equals -4. Divide by 5. I get, I'm going to write it over here. I get x equals -4 over 5. Let me rewrite that a little better. Whoops. So I get -4 over 5. And then here, subtract 2 from both sides. I get x equals -2. Add 2 to both sides here, I get x equals +2. And then if I write those as intercepts, I get -4 over 5, comma, 0. I get -2, 0, and +2, 0. And then I need to find my y-intercept. And I do that by setting x equal to 0 and solving for y back into the original equation. So I'm going to get y equals -16 when x is 0. And all I have to do now is plot all my intercepts. So 0, -16 is going to go through there. And then the x-intercepts are at 2, 0, -2, 0. And -4/5 is really close to -1. If it helps you, you could write that as a decimal. And I know that it goes down to the left, up to the right, so it's going to go down here and then go through that intercept, through my y-intercept, and back up. So we found all the key features, which are positive orientation, third degree polynomial, all the intercepts, and graphed our function. And that's it for today's lesson.